8-point line, we talk more about segments within angles. So, like radii and diameters, chords, tangents, secants. So we dealt with segments and lines with circles. This lesson we're going to talk more about angles. And there's multiple types of angles involving circles. We're just going to focus on two of them. Central and inscribed angle. Okay. Two important types of angles that you should know involving circles. First thing we're going to talk about is the central angle. Central angle just means the vertex is on the center. So if we have angle ACB, that is a central angle. Its vertex is on the center of the circle. Okay? So our central angle is angle ACB. The intersected arc just means the arc that's like inside the angle. So if we start on the mouth of the angle, or opening of the angle at one end, and go to the other, that is the intersected arc. I like to think of it like, if you notice, this looks like a piece of pizza or a piece of pie. The green part looks like the crust. The intersected arc is just kind of the crust of that piece. Okay. So that is arc AB. It's important to note that the measure of the angle is always equal to the intersected arc. So in this example, if the angle is 73, the arc is 73. If the arc is 73, the angle is going to be 73. The central angle and the arc are always the same. Well, let's practice this a bit. We want to find angle COD. Angle COD, this yellow angle is right there. So whenever an angle is missing, go to the arc. That will help you find the angle. What type of angle is COD? It's central, right? It's on the center. So what do we know about the angle in the arc? The same. So if the arc's 58, what's the angle going to be? 58. So angle COD is 58 degrees. Next one we want to find is arc BC. Arc B to C. Well, if the arc's missing, go to the angle. Here's the angle that matches up with that arc. And it's central. So what do we know about the angle and the arc? They're the same. So if the angle is 32, what's the arc going to be? 32. So this arc is 32 degrees as well. The next one wants us to find arc AB. It wants us to find this blue arc. We'll do yellow. It wants us to find this yellow arc right here. Very good. Good job. This whole arc from A to C right here, from A to C, is 180. It's a semicircle. Semicircles equal 180 degrees. If we take away BC, the green arc, that will leave us the measure of the yellow. So all you have to do here is just do 180 minus 32, and that will tell us what AB is. What is 180 minus 32?
148.
148. So that arc is 148 degrees. If we take a look at D, we want to find arc DAB, which is this dark blue arc right here. What do you think we need to do to find that dark blue arc? Yeah, 360 good. Minus. Yeah. Yeah. Subtract those two arcs that make up the red part from 360, and that will give you the entire blue arc. So 360, I'm going to write it down here somewhere in my room, minus 32, minus 58, and that will give us the blue arc.
280.
Close.
270. Oh my God. So
that's 270 degrees. Questions over that? Okay, that's central angle. I like to think of these as little puzzles. I really like this lesson. Like little puzzles. How do you find the missing pieces? Another type of angle is an inscribed angle. And that's where the angle is on the edge of the circle. So if I have this angle right here, here's my inscribed angle, angle ACB. The vertex is on the edge. C is on the edge of the circle. The intersected arc, again, is what's connecting the kind of mouth of the angle A to B. So that is the intersected arc. And it's important to note, with inscribed angles, they are not the same. The arc and the angle are not the same. You notice, if I make a kind of representing the measure of the angle there, they're not the same. That little blue arc is not the same as the big blue arc. They're not the same measure. Okay? The angle is half of the arc. Or the arc is double the angle. So inscribed angles and the arcs are not the same. The angle is half the arc. So if you're going from little angle to big arc, multiply. If you're going from big arc to little angle, divide. And you're multiplying by 2 or you're dividing by 2. You're either doubling the angle to get the arc or cutting the arc in half to get the angle. Okay? So let's practice. We want to find x. Well, I notice x is inside this angle, which is on the edge. It's on the edge, so it's inscribed. When the angle's missing, go to the arc. What's the measure of the arc? 102. We're going from big arc to little angle. So let me make an arc with this. Big arc to little angle. So what do we have to do with 102? Divide. Cut it in half. What's 102 divided by 2? 51. So x is 51 degrees. Big arc to little angle divide, little angle to big arc multiply. If we take a look at the next one, find ACB. Well, when the angle is missing, go to the arc. It didn't tell us what that arc is, but we can find it. How can we find that green arc? Really similar to the previous problem we did. How can we find that green arc? What do we know about the measure of an entire circle? 360. So what can we do with 89 and 153 to find that green arc? You're on the right track. You're on the right track. We can subtract them from 360. An entire circle is 360. Subtract the two other arcs, and that will tell us what the green arc is. What is 360 minus 89 minus 153? What is it? 218? Check. Everyone agree? What's 218? I feel like we have a different answer for 218. Sorry. Go 218. That's why we have calculators. So we have that arc, which is 218. What do we have to do with the big arc to get the little angle? Divide it. So it's 218.
It's 118.
118. I heard 2. So it's 118. That's why we just check. Make sure I'm writing the right thing. Hard to hear. So we're going from big arc to little angle. We divide. What's 118 divided by 2?
69.
Questions over that? If we take a look at C, it should say A. That's a typo. I thought I fixed it before I printed it, and I didn't. I caught it, but I just didn't change it apparently. Make sure phones are away, please. You shouldn't have phones out right now. Really no need. Okay. I feel like that can also be distracting. If we take a look at A, angle. When the angle's missing, go to the arc. What type of arc is that? It's half a circle, which it equals what? It's a semicircle, so it's how much? 180. Again, we're going from big arc to little angle. What do we have to do with 180? Divide. What's half of 180? 90. So that angle is a right angle. That's true. Every single time you have an inscribed angle and this arc is a semicircle, it's always going to equal 90. So a little fact. If you can remember it, great. If not, just do the work and you'll still get the right answer. So sometimes inscribed angles and central angles are in the same problem, and you need to be identified which one's which. You're not going to be told, oh, this angle is an inscribed angle. Find it. Or, oh, this angle is a central angle. Find the arc. You are going to have to determine which is which. Okay? So, if we take a look at A, here's our angle. Is that central or inscribed? We need to identify is angle ABC central or inscribed? Central. It's on the center. What do we know about central angles in the arcs? They're the same. So if the arc's 35, what's the angle going to be? 35. If we take a look at B, here's the angle. We need to identify this angle. The B got cut off, but ABC. Is it central or inscribed? Inscribed. And we want to find the angle. So we're going from big arc to smaller angle. What do we have to do with 44? Cut it in half. What's 44 divided by 2? The measure of that angle is 22 degrees. We take a look at C. We need to identify angle LKJ. Is it central or inscribed? Inscribed. The vertex is on the edge. This time we're going from little angle to big arc. We're going to multiply or divide? Multiply. You're going to do 96 times 2. What is 96 times 2? 92. So that arc is 192 degrees. Last one here, we have to identify this angle. Is that central or inscribed? It's central because it's on the center. Here's the missing arc. What do we know about central angles in the arcs? They're the same. So the angle is 139. The arc is also going to be 139. Questions over that. So here we go. Here's an example where they're both in the same problem. We need to find x. X is representing this angle. So when the angle's missing, go to the arc. I don't know what that arc is, so I have to use the other information in my diagram to help me find that arc. The only other information they gave us was this angle right here. This blue angle. Well, what type of angle is this blue angle? It's on the edge, so it is inscribed, right? So if the inscribed angle is 41, it's intersecting the same arc, so we're going from little angle to big arc. What do I have to do with 41? Multiply. What is 41 times 2? 82. So we know this arc is 82 degrees. X is representing a central angle. What do we know about the central angle in the arc? They're the same. So x is equal to 82. The arc's 82. The angle's going to be 82. For B, we want to find this inscribed angle. It's on the edge, it's inscribed. Well, when the angle's missing, go to the arc. We don't know the arc either. So use the other information in the diagram to find it. Well, they only gave me the central angle, which is intersecting that same exact arc. The two angles share an arc. So if the central angle is 162, what's the arc going to be? 162. Again, central angle and the arc are the same. Now that I know what that arc is, I can find the inscribed angle. What do I have to do with 162? We're going from big arc to little angle. We're going to divide. What's 162 divided by 2? So this angle is 81 degrees. So shortcut, if an inscribed angle and a central angle share the same arc, it's kind of, the inscribed angle is always half the central, or the central is always double the inscribed. So if you don't remember that, just do what we did here and you'll get the right answer. Another example where they are all in the same diagram. It's saying arc BC is 34 degrees. So I'm going to mark it and label 34. We want to find all three angles. Okay, so we're going to find angle 1, angle 2, angle 3. Well, which one can we find pretty quickly? There's two that we... 3, right? 3 is the central angle, so what's its measure? Yeah, it's the same as the arc. So that arc is 34. The angle's 34. So angle 3 is 34 degrees. What's another one we can find pretty easily? Angle 1. What type of angle is angle 1? Inscribed. It's on the edge. Well, to find the angle, what do we have to do with the arc? Divide. Big to little, divide. So we're going to do 34 divided by 2, and we get what? 17. Angle 1 is 17 degrees. Angle 2 is going to require a little bit of work. Angle 2 is not an inscribed angle. The vertex is on the edge, but this side right here, the green part of the angle, doesn't go all the way to the other edge. It stops at the radius. So it's not inscribed. Everything has to be on the edge for it to be an inscribed angle. We can't find the arc and cut it in half. It doesn't have an arc. It doesn't go all the way to the edge. But I notice here, erase some stuff to make it a little bit neater. What type of shape do we have here? That's not right, but it is a triangle. We know this is 17, and we know this is 34. I heard someone say it. What type of triangle is it? Isosceles, right? How did you know it was isosceles? You're right. Aren't these both radii of the circle? This blue and this green segment, aren't those radii? And are all the radii the same in the same circle? So isn't this an isosceles triangle?
Yeah.
What do we know about the angles across from those sides in an isosceles triangle? If these sides are the same, the angles are going to be the same. So that's 17, 2 is going to be 17. That's one way you could have found it. Here's another way. Maybe you didn't recognize that that was an isosceles triangle. Okay, if you didn't recognize that was an isosceles triangle, here's what you could have done. We know this is a triangle. Okay. We know this is 17, and we know this was 34. Here's what you could have done. We also know this arc is 34. If we can find this angle, we can easily find angle 2. Because what do all the angles of a triangle add up to? Oh, go dear. What do all the angles of a triangle add up to? 180, right? So if we can figure out what this angle is right there, we can find angle 2. Well, when an angle is missing, go to the arc. This is another central angle. So we can find the arc right there. Well, we have a semicircle. So what can we do with 180 and 34 to find that missing blue arc? Subtract it. What is 180 minus 34? 146. So if this arc is 146, what's this angle going to be? It's central. So it's the same. It's also going to be 146. We know all the angles of a triangle add to 180. So we do 180 minus 17 minus 146, and it will give you 17. So if you don't recognize that that's an isosceles triangle, You have to do a little bit more work, but you still get the right answer. Okay? Again, that's what's great about geometry. A lot of the times, there's multiple ways to get the same answer. So if we take a look at the last example here, another fun fact about circles. Whenever you have a quadrilateral inscribed in a circle, meaning all four angles are inscribed angles. So we have a quadrilateral where all four angles are inscribed angles, meaning all four vertices of the quadrilateral are on the edge. The angles across from each other are always going to be supplementary. What does supplementary mean again? They add to 180. So we look at this diagram here. X is across from which angle? What's opposite of X? 80, right? So to find X, all we have to do is just do 180 minus 80, and we get 100. So X is 100 degrees. To find Y, what angle is across from Y? 71. So to get Y, just do 180 minus 71. And it gives us 109 degrees. Again, if you don't remember that fact for this particular problem, you would just use what you knew about inscribed angles to help you find those missing ones. Okay. For B, you can't really get away with that. You kind of have to know the fact for B. We want to find X. Well, I notice these are inside a quadrilateral where all four angles are inscribed angles. Well, X are two, they're both angles that are across from each other. What do we know about those two angles? They add to 180. So you add them to 180 degrees. And then solve for X. Combine your length terms, you get 44X plus 4 equals 180. Move 4 over. So we get 44. X is equal to 176. Divide by 4. So X, or 44. So X ends up equaling what? So it's 176 divided by 44. It is 4. So X is equal to 4. Questions on that?